4 people just came back from the moon, and they are not the same people who left. Not in some poetic, philosophical sense. They were biologically different. At the cellular level, their bodies were rewritten by forces that do not exist on Earth, and the changes are permanent. But here is what makes this story stranger than a standard space mission. The crew knew exactly what would happen to them before they climbed into that capsule. They trained for it, studied the medical literature, and accepted all of it. What their bodies endured out there has never been fully captured in any press conference or mission debrief. The data is still coming in. Some of it is unsettling. Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen splashed down in the Pacific Ocean on April 10th, 2026, after spending 10 days beyond the protection of Earth's magnetic field. They became the first humans to leave low Earth orbit in over half a century. The first to venture that far into deep space since 1972. What happened to them out there? What their bodies endured, what their minds experienced, none of it fits neatly into a headline. So let's start with what we can actually measure. Radiation. In low Earth orbit, astronauts aboard the International Space Station are shielded by Earth's magnetosphere, this massive invisible bubble that deflects the nastier particles the universe throws at us. That's why International Space Station crews can spend months up there without turning into walking tumors. The Artemis II crew punched through that shield twice. Once on the way out, once coming home. Both times they passed through the Van Allen radiation belts, concentrated bands of charged particles trapped by Earth's magnetic field, swirling like flies caught in amber. Beyond those belts, there's nothing between you and the cosmic radiation streaming from distant supernovas, solar flares, and the general hostility of deep space. During their 10-day journey around the moon, the crew absorbed a radiation dose roughly equivalent to a full-body CT scan. That does not sound catastrophic until you understand what that radiation actually does. It does not pass through you like light through glass. It collides with your DNA, snaps molecular bonds, scrambles genetic instructions, and triggers mutations that your cells may or may not catch and repair. Studies on rodents exposed to the same high-energy particles found reduced dendritic complexity in brain cells, altered spine morphology in neurons, and disrupted synaptic integrity. The neuroinflammation persisted for over 6 months after the exposure ended. In plain terms, the radiation physically changed the architecture of their brains. And we are not guessing. NASA's own twin study from 2019 showed that astronauts returning from long-duration missions exhibited lasting alterations in DNA and cognition. The changes did not fade after a few weeks of recovery back on the ground. The astronauts aged faster at the cellular level. Their brains showed signs of damage consistent with premature aging. That study involved astronauts who never left Earth's protective bubble. They stayed inside the magnetosphere the entire time. The Artemis II crew flew straight through it and out the other side. Now here is where things get visceral. What microgravity does to the human body might be even worse than the radiation. Within hours of reaching zero gravity, approximately 2 liters of fluid that normally pools in your legs shift upward into your torso and head. Your face swells, your sinuses clog, you develop what is called moon face, a puffy, congested appearance that can make you look like you have been crying for hours. That is cosmetic. The real damage happens inside. Your heart, no longer working against gravity to pump blood upward, starts to shrink. Cardiac atrophy. Your cardiovascular output spikes by 18 to 26% as your body essentially panics, trying to figure out what is happening to the fluid dynamics it has relied on for your entire life. Then it crashes back down. Blood volume drops by 10 to 15%. Red blood cell production slows. You develop space anemia. Meanwhile, your bones, no longer bearing any weight, begin leaching calcium directly into your bloodstream at roughly 1% bone density per month. Your muscles, particularly in the legs and lower back where you would normally carry your body weight, atrophy rapidly. Weight-bearing muscles can lose up to 20% of their mass in just a few weeks of weightlessness. The crew fought back with daily exercise on a flywheel resistance system bolted beneath the hatch. 30 minutes a day, every day except launch and landing. It helped, but you cannot fully counteract what happens when gravity stops being part of the equation your body was built around. Evolution spent millions of years optimizing the human skeleton and cardiovascular system for 1 G of constant downward pull. Remove that pull for 10 days, and the machine starts breaking down. Then there is what happens to their eyes, and this might be the strangest problem of all. The fluid shift toward the head increases intracranial pressure, which deforms the eyeball and flattens it slightly from behind. The optic nerve swells. Some astronauts develop spaceflight-associated neuroocular syndrome, SANS. That causes blurred vision, visual field defects, and changes that can persist after landing. Roughly 70% of astronauts on long-duration missions show signs of it. Christina Koch, who held the record for the longest continuous spaceflight by a woman before Artemis II, knew about these effects firsthand. She went anyway. Imagine your brain slowly pressing against the inside of your skull because the cerebrospinal fluid that normally drains downward simply cannot. That is oversimplified, but it captures the basic horror. Reed Wiseman had his vision tested multiple times during the flight using equipment that measured his eyeball shape in real time. That data feeds into models predicting how long humans can safely operate near Mars without permanent vision damage. But here's what the medical data can't fully capture: the psychological transformation. Jeremy Hansen described looking back at Earth from the far side of the moon as an experience that bent his mind. He said it felt like they'd been transported, not just physically moved through space, but fundamentally displaced from reality. The Orion capsule disappeared from his awareness. All that existed was the moon's ancient, battered surface beneath them, and the tiny, fragile Earth hanging in the blackness behind it. Victor Glover called the views science fiction. Not like science fiction. He said they were science fiction, as if the human brain does not have the reference points to process what it is seeing, and defaults to treating the whole experience as unreal. They watched the sun rise over the lunar horizon while Earth set behind them. They saw terrain no human eyes had witnessed in over 50 years. They experienced a solar eclipse from behind the moon that lasted 54 minutes, nearly an hour of totality impossible to see from Earth. Christina Koch said it most directly. Looking through Orion's window, watching Earth shrink to the size of a thumbnail against infinite darkness. She realized something that changed her permanently. Planet Earth, you are a crew. She meant it literally. Every person she had ever known, every human who had ever lived, was part of a single fragile system sustained by a thin band of breathable atmosphere she could see in its entirety. Everything outside that band was instant death. No borders visible, no nations, no divisions that carried any meaning from 250,000 miles away. Scientists call this the overview effect, and it is not a metaphor. Brain scans of astronauts who have experienced it show measurable structural changes in how their brains process information about self versus other, individual versus collective. The neural pathways physically reorganize themselves. What they see from that distance rewires who they are at a neurological level. And for the first time in history, NASA had modern neuroimaging technology to pair with the experience. The Artemis II crew underwent detailed brain scans before launch and after splashdown, and early findings suggest measurable reorganization in the regions that handle empathy, perspective-taking, and group identity. The crew talks about feeling bonded in ways that transcend normal friendship or professional respect. Wiseman said no one outside their crew will ever truly understand what the four of them experienced together. That is not poetic exaggeration. It is neurological reality. Their brains processed shared experiences so extreme, so far beyond any normal human frame of reference, that the memories literally reshaped how they relate to each other and to every other person on Earth. Hansen captured it differently. Standing on the recovery ship in the Pacific with cameras on his face, he said something that cut through every piece of technical analysis. When you look up here, you are not looking at us. We are a mirror reflecting you. The crew's transformation is only half the story because the scientific payload they carried home tells us something far more troubling about where we are headed next. While their cells were being altered by radiation and their bones were quietly losing density, instruments aboard the Orion capsule were collecting data no crewed spacecraft had gathered in over 50 years. The Avatar payload, tucked inside the crew module, held something unprecedented in space medicine. It contained bone marrow cells derived from the crew's own blood samples, sealed in specialized containers designed to survive the radiation environment beyond Earth's magnetic field. Those cells are now sitting in laboratories, being analyzed at the molecular level. Researchers want to know exactly what galactic cosmic rays do to human tissue when there is no atmosphere to filter the particles and no magnetic field to deflect them. The early results are complicated. For a 10-day mission, the damage is measurable but manageable. There were chromosomal aberrations and DNA strand breaks, but they were within ranges the body's natural repair mechanisms can handle. The real concern is not 10 days. It is what happens when you extend that timeline to months and years. Mars is the actual target, and a Mars mission means 2.5 years in deep space, minimum. The Artemis II data provides the first modern baseline for what that journey will cost in accumulated cellular damage, and the numbers coming back from the labs are not encouraging. If you're finding this deep dive valuable, hit subscribe. I cover space science and human exploration every week. Tissue studies show persistent neuroinflammation lasting 6 months after a single radiation exposure. Synaptic connections in brain tissue, the junctions where neurons communicate with each other, show disrupted integrity. Dendritic spines, the tiny protrusions that receive signals from other neurons, become physically malformed. This is not theoretical modeling. This is what happens to living tissue when it gets hit by iron nuclei traveling at 98% of the speed of light. And there is no shielding technology that can fully stop them. They punch through aluminum, through water, through human flesh, as if none of it is even there. The radiation dose Artemis II received was modest by deep space standards. But computed tomography scans do not last 10 continuous days. They do not bombard you non-stop with particles that ignore every barrier you put between yourself and them. The crew's immune systems are being closely monitored because animal studies show radiation scrambles immune responses in ways that persist long after the exposure ends. Cytokine profiles shift. The body's ability to fight infection degrades. White blood cell counts fluctuate unpredictably. Christina Koch is uniquely valuable to researchers because her baseline was already established from 328 days on the International Space Station. Scientists can now compare her pre-International Space Station data to her post-International Space Station data and then to her post-Artemis II data, mapping how different radiation environments affect the same body over time. The chromosomal aberration rate decreases somewhat after a first flight, suggesting adaptation. But it never returns to baseline. A second flight does not proportionally increase the damage, which hints at radiation hormesis. The idea that low-level exposure might trigger protective responses. Maybe. The data is not conclusive. What is conclusive is that every astronaut beyond low Earth orbit accumulates damage that never fully heals. The cardiovascular system tells its own story. 2 liters of fluid shifted from the crew's lower bodies to their heads during the mission, forcing cardiac output to spike by as much as 26%. Their hearts were working harder, pumping blood that had nowhere to pool because gravity was not pulling it downward anymore. Over 10 days, that is manageable. Over months, the heart actually shrinks from cardiac atrophy, reducing aerobic capacity and making something as simple as standing upright after landing a genuine physical challenge. All 4 crew members tested compression garments during the flight designed to counteract orthostatic intolerance, the condition where blood pressure drops so sharply upon standing that you faint. Apollo astronauts experienced it. Skylab crews dealt with it. International Space Station astronauts still struggle with it after long missions. The garments help, but they are a patch over a fundamental problem. Human bodies evolved in 1G. Remove that G, and everything from cellular metabolism to gross motor function begins drifting away from normal. Microgravity adds another dangerous layer. Microgravity alters cytokine profiles, the signaling molecules that coordinate immune responses. White blood cell counts shift unpredictably. The body's ability to fight infection drops measurably, not catastrophically on short missions, but enough that a simple bacterial infection during a Mars transit could become life-threatening without proper medical equipment aboard. And the crew's blood work shows the immune system starts changing within hours of reaching microgravity, not days, which is faster than anyone had predicted. Sleep disruption compounds everything. Without the day-night cycle Earth provides, and without gravity pressing you into a mattress, sleep becomes fragmented and shallow. The crew slept in bags tethered to walls, floating in the dark while their brains tried to make sense of an environment where up and down meant nothing. Circadian rhythms drifted, and cognitive performance measurably declined. NASA tracked the crew's sleep using wearable sensors that monitored heart rate variability, movement patterns, and time. Spent in different sleep stages. The data confirmed what astronauts have reported for decades. You never sleep in space the way you sleep on Earth. You adapt somewhat, but it is never the same. Now take all of that and multiply it by 2.5 years. The radiation damage accumulating in their DNA every single day. The bones losing density month after month with no load-bearing activity to slow the loss. The heart slowly shrinking from cardiac atrophy. The the immune system running at reduced capacity, unable to mount a proper defense against even basic infections. The chronic sleep deprivation grinding down cognitive sharpness week after week. That is the Mars problem. A crew that is simultaneously losing bone mass, collecting genetic mutations, fighting immune dysfunction, and operating on degraded sleep while still 6 months from their destination, is a crew operating on borrowed biological time. And the psychology makes it worse. 4 people got along beautifully on Artemis II. They were selected partly for interpersonal compatibility, trained together for years, trusted each other completely, and knew the end date was 10 days out. Extend that to 3 years in a habitat the size of a small apartment with no way to step outside, no fresh air, no rain, no sunlight filtering through trees, and the dynamics change completely. Skylab crews in the 1970s experienced real interpersonal tension during missions lasting just weeks. ISS crews have dealt with genuine conflicts during 6-month rotations. One Mars crew simulation conducted on Earth had to be terminated early because the participants could no longer function together as a team. And that happened on solid ground, where every person involved had the option to open a door and walk outside and quit. On a spacecraft traveling to Mars, there is no door. There is no walking away from anything. The Artemis II data feeds into models trying to answer these questions. How long can humans maintain cohesion in extreme isolation? What warning signs indicate a crew is approaching psychological limits? Can you screen for resilience during selection, or does everyone eventually hit a wall? NASA knows all of this. The exercise protocols being refined on Artemis missions feed directly into hardware being designed for deep space habitats. But you can't just scale up a flywheel and call it solved. The human body needs actual load-bearing stress, real weight pushing down through bones and joints to maintain mineral density. Rotating spacecraft that generate artificial gravity through centrifugal force might work. Nobody's built one yet. Pharmaceutical interventions, drugs that slow bone loss or stimulate calcium retention, are being tested in parallel. None of it is ready for a 3-year round trip to Mars. The musculoskeletal damage alone would horrify an orthopedist if sustained for months instead of days. ISS astronauts who spend 6 months in orbit lose up to 20% of their bone mass in specific areas. 10 days is manageable, but 6 months to Mars is not. So what did Artemis II actually prove? The Orion capsule's heat shield held during re-entry. The life support system kept 4 humans alive and breathing. Radiation stayed within acceptable limits for a short mission. The basic engineering is sound. 4 people flew farther than any humans in 53 years and came home alive. But the cost was written into their cells before they ever launched. Altered DNA that will never fully revert. Neural pathways restructured by experiences their brains still can't fully categorize as real. Weaker bones. A cardiovascular system that had to relearn how to function under gravity. They knew the price before they agreed to pay it. They paid it because some knowledge can only be purchased with transformation, and what they learned during those 10 days changes the trajectory of everything that comes after. Mars isn't a dream anymore. It's an engineering problem with a biological price tag, and thanks to 4 astronauts who volunteered to let deep space rewrite their biology, we're finally beginning to calculate what solving it will cost. Now go look up the overview effect. Once you understand what it does to the brain, you'll never look at Earth the same way again.